the math workshop for today, since clearly we need to. I would say we skip this example, but you'll never get your checkpoint done if you're still, well, you could, that's a lie. But we'll do one more to make sure you're completely good to go. We're going to take a quiz on 4.1 on Tuesday. I originally said Monday, but we've talked about, we've got one more thing we got to discuss before we can quiz. So the quiz is going to be Tuesday. Page 7, which I know Kenzie already showed me. Page 7, 1 through 6 are going to be due as soon as you get them done. I know they were the same thing top and bottom. There were 6 different parts. Start off with a 5. Any points you get are bonus. 6 different parts, so it's 36 points. She's already got her 36 out of 36. That's what we're going to work on when I stop rambling. We're also going to work on our checkpoint. The first question on the checkpoint's easy. The second question looks like the one example we're about to work today, where it ends up being decimal, so you're going to have to use that handy-dandy calculator. Okay, back to the one example that Arturo chose. Arturo said, let's work number 1 on page 3.
For the vertex.
Let's answer the obvious stuff first before you go answer the hard stuff. So I have vertex, max, min, domain, range. What's missing from this list that I like to see?
A graph.
Well, I don't have to see a graph. You're going to graph it on the calculator.
Maximum and minimum.
It has max and min.
Okay.
What's it missing? Say it. I changed that to y-intercept, so you just can't. Oh, you can't see what I'm doing. Oh, you can get a point for that because you can see my math. Come on in autofocus.
Camera.
Yes, ma'am. The axis of symmetry is missing. You can have a point for that. Okay, but some of these we can automatically fill in. Which ones can we automatically fill in?
The maximum.
Is it a max or is it a min?
It's max.
It's a max, and you can have a point, and so can they. And then there's another one we can automatically fill in. Is what?
Negative infinity.
Yes, Seth gets the point. He said that first, and then yes, ma'am. Tell me about that y-intercept. What would it be? It's at 4. I don't care if you put 4 or 0, 4. Either one's great with me. So seriously, we filled in half the stuff, and we haven't even graphed it yet. That's crazy. Okay, I've already graphed it on my calculator. Hopefully you've graphed it on yours. If not, do so now. Okay, and Arturo was going to tell me about the vertex, I believe.
Mm-hmm.
What were you going to tell me about that vertex?
It was negative 156.
Negative 1.5, comma 6?
Yes.
Okay, and he's probably right. So let's talk about why this one's a tricky one. When we look at it...
Because it's off the tracer is off the...
And don't get mad at me for writing on my calculator. It is my calculator, by the way. So negative 1.5 does look where that axis of symmetry is. But it's between 1 and 2. And again, we're just guessing. And I don't like it when I'm just guessing. So we're going to calculate it in just a second. If it's a nice, pretty whole number, what can we use? What feature of the calculator do we like to use? When it doesn't turn off for us. If it wasn't a decimal, and it was a pretty whole number, what would you press from here to figure out where that vertex is? Trace is kind of a bummer. I mean, trace, it kind of looks like negative 1.56, but trace is exactly what it sounds like. It's guessing. It's tracing. I don't really feel like it's exact. Let's just zoom in and out on the graph. If we go to the table. So second table. Okay, so you told me it was a max, so what am I looking for in that second column?
The maximum number.
Exactly, get another point for that. So we're looking for the highest number. Now you can scroll up or down and try to find that highest number. And my table is set weird. Someone set my table weird. How dare they? So I'm scrolling up and down. Second table. I can scroll. Come on, table. Second table. Miss Brister, we said one and done today. That's why we were one and done in it.
We're one and done.
One and done. Okay, and I run into an issue with my table. What's my issue?
It's on about one.
Yeah, but what would you tell me the max is right now? Yeah, but which one do I pick as the vertex? Do I pick negative 2.6 or negative 1.6?
Negative 2.6.
Now you're just guessing now, so we don't know. You would say maybe it's halfway in between, so negative 1.56. So I would say it's probably the average of the two, so negative 1.56. But still, I don't like guessing. Now that ends up being the correct answer, so Arturo figured it out with trace. You could probably guess it with the table. But again, we're just I don't like this ballpark estimating. I want the calculator is smart. If I ask it nicely, it will tell me the dead-on, exact, approximate answer as it can get. So I'm going to ask it to. What's a better button to press instead of table? Yes, you can have a point for that. We're going to press calc. If we press second calc,
I said it too.
he did say it too. If he said second calc, and you've already told me, is it a max or a min? It's a max. So we pick a little to the left, and see, I don't think I've done this well before, so, or maybe I did, or I don't know. We can go over it again. So I understand that I think, let me scroll a little more, that this point up here at the top, I think that's where my vertex is. I think that's the max. I'm just needing to find its exact value. So now that I'm getting my calculator to calculate stuff, it says left bound. So we just have to press enter somewhere to the left of that point. So like right now is great. Here's great. Further down's great. It doesn't matter. So you press enter. As long as it's to the left of the point, you're good. And then right bound, well, that has to be to the right of the point we want. So I could press enter here. I could keep going and say, oh, I'll press enter here. It does not matter. And once you set your region, you're telling the calculator, hey, I think there's a max between here and here. This is where that max is happening. It's happening in between here and here. So the only way you can mess this up is if you don't actually have that region within that little range. And then the one part of the calculator that I would change if I could is it makes you guess. Now you can scroll over and try to guess the real one. Doesn't matter. Once you enter even a terrible guess, it tells you the real answer. So it was negative 1.5, but it's not 6. It's 6.25. So we were going to guess negative 1.56, and we would have been wrong because it's negative 1.5, 6.25. Are there any questions of how I use that magic feature on my calculator? You have to use that feature on number 2 of the checkpoint, or we'll talk about the or in just a second. So I know my vertex is at negative 1.5, 6.25. What number do I put for max?
Max.
What is the max?
It was what you could make
It's the same thing.
Is it the whole vertex again? Which coordinate of the vertex is it? The y. Thank you, dear. You can have a point. So it's going to be just 6.25. Okay, and I also know my axis of symmetry. What's my axis of symmetry? Yes, so the x coordinate of the vertex tells you the axis of symmetry. The y coordinate of the vertex tells you the min or max. And that y coordinate also helps us with the range. What is the range of this function?
6.
We know it involves at 6.25, but is it negative infinity to 6.25 or 6.25 to infinity?
Negative infinity to 6.25.
Yes, I could touch it at the bottom for forever, but at some point at the top, I stop. So it's negative infinity on until 6.25. Okay, Miss Compton puts it in a bracket. Why do I put the 6.25 with a bracket and not a parenthesis?
because it's not.
Well, it's not an infinity. That's true, but why? What does the bracket imply about it? I can touch it. Yes, Reagan, you have a point for that. I can actually touch it at that point. Remember, we used to have like open circles if we couldn't touch them, but I can touch it. See, I'm touching it. Okay, so that is what we're going to do. Now, that's how I would handle number 2 on your checkpoint, but that is not how Miss Brister would handle it. Miss Brister likes formulas. She doesn't really love her calculator that much. I mean, she does, but she'd rather do a formula. So instead of doing all this hocus pocus, she remembers the formula for the axis of symmetry is negative b over 2a. So in our case, we know it's negative. Our b is, let's see, a is negative 1, b is negative 3, c is 4. So negative b would be negative 3, negative 3. Over 2a, well, a is negative 1. So she would get positive 3 over 2, which is 1.5. Oh, I did that wrong. It's a negative 3 over 2, which is negative 1.5. Miss Compton can do math today. So Brewster doesn't actually use her calculator to figure out that axis of symmetry, and then she already knows that x-coordinate of the vertex. Now from here to figure out the 6.25, she genuinely just plugs it in her function. So, everywhere it used to be negative x squared minus 3x plus 4, but now everywhere she sees an x, instead she puts negative 1.5. Now, I think she's working really hard, and what she does is always going to work, yes. And she's still going to get the 6.25, and she's still going to have all the answers, yes. But it's fine with me if you're lazy and just say, hey, calculator, can you help me with this? But Brewster does have one advantage over me. What is that? Test-wise.
She has the formula down pat.
She does have a formula, which means she's showing some work. I'm not showing any work. So I understand why she might want to do it her way, to have a little work to show. Okay, again, I think this side, well, I can't vouch for this. I can't even lie and tell you I didn't. Okay, were the 6 that you had to do normal? Do they all have, or were they any decimal ones? Okay, so the only decimal one you have to do is number 2 on the checkpoint, or at least that's what Kenzie and I think. But it is Friday, so we make no promises.